exploring the resilient and secure data center logical, physical, and environmental design. Additional topics will include cloud infrastructure risk assessment, cloud vulnerabilities, threats, and attacks, and finally, cloud risk mitigation strategies. This is one of a collection of courses that fully prepares the learner for the ISC Squared Certified Cloud Security Professional CCSP 2022 exam. Of course, this first lesson looking at the logical approach to cloud computing or cloud data center, and for most organizations, this environment, whether it's a new environment or some upgrade environment, is going to be what we call terraformed. In other words, you're going to use infrastructure as code for your logical design, and that will drive what the actual physical design is in the cloud. Infrastructure as code is typically a single YAML, Y-A-M-L, or JSON document that represents the entire architecture from a logical standpoint. And you can use tools of the cloud provider. For example, you could use AWS CloudFormation. You can use third-party tools, or before you do this yourself, you might use a site such as Lucidchart that gives you the ability to build out this infrastructure as code design, and then you can follow through on the implementation using automation tools and terraforming tools at the cloud provider. And this is going to be things like your virtual networks, your virtual machine deployments, front-end, middle-tier, back-end database deployments, your container DevOps environment, and more. Today, we represent our underlying network topologies, whether it be the on-site data center or in the cloud, using software-defined networking, or SDN. Here, we get total separation between the control plane and the data plane. The control plane and the SDN controller are what manage the clusters of hypervisors running our applications. We're also going to use a special type of controller, for example, a Cisco APIC, to actually send API calls to manage the devices in the different planes. Usually with SDN, we're using traditional VLAN or private VLAN, but in a large data center, we've moved to a more robust VXLAN, virtual extensible LAN environment with leaf switches and spine switches. If you're a Cisco engineer or you worked with Cisco equipment, you understand the need for software-defined networking as an evolution in network design. For decades, we had different Cisco devices without clear separation between the data plane and control plane. We had multiple operating systems. We had different types of graphical user interfaces and CLIs, and even trying to attempt a unified, centralized management was impossible till we moved to a more software-defined networking solution, which, by the way, Cisco calls ACI, Application-Centric Infrastructure. There are several attributes of software-defined networking. It's agile. You can logically and dynamically adjust network-wide traffic flow to meet changing requirements. It also maps to your project management. Centrally managed. Logical network intelligence centralized in SDN controllers maintain a global view of the network, and no longer are we managing devices with direct in-band or out-of-bound access. Now, we're logging on to controllers as administrators and sending digitally signed API calls to all of the infrastructure devices. This allows us to be programmatically configured. Network managers can configure, manage, secure, and optimize network resources rapidly using dynamic automated SDN programs. And SDN should be open standards-based and vendor-neutral. This simplifies network design and operation by SDN networking controllers as opposed to multiple vendor-specific devices, protocols, and interfaces. One of the main advantages of software-defined networking is software-defined security, SDS. SDS exploits the software-defined networking initiative to enhance network security by tightly controlling the environment, often using virtualization and terraforming. The functionality of network security devices, such as the next-gen firewalls, intrusion detection and prevention, IDS, IPS, as well as our identity and access controls and network segmentation, are removed from hardware devices and moved to a logical software layer. Advantages of SDS include the enabling of centralized management of security, which is implemented, controlled, and managed by security software through the SDN controller. This is often a special software package running on a Cisco server. It gives you visibility of information provided from one source. It enables resourceful and dynamic countermeasures to security attacks. It removes security from traditional hardware management vulnerabilities, such as SNMP, syslog, Secure Shell version 1, and SSL. You can dynamically configure existing network nodes while allowing for rapid attack mitigation from zero-day attacks, or attacks that show up for the first time in the wild and happen to be on your network or in your cloud environment. You get a synchronized view of logical security policies, and these exist within the SDN controller module. You can correlate events and respond more efficiently and intelligently to threats with Security Information and Event Management SIEM and Security Orchestration, Automation and Response SOAR. And SDS facilitates Internet of Things IoT and the rapid deployment of BYOD, Bring Your Own Device connectivity and security. Modern corporate data centers and cloud data centers have moved away from traditional VLANs with their 12-bit identifier, accommodating 4094 VLANs, to the Virtual Extensible LAN, VXLAN. It's an encapsulation protocol that offers data center connectivity using tunneling to stretch Layer 2 connections, logical connections, over an existing Layer 3 network. Solutions from vendors decouple the physical hardware from the network map in order to support virtualization and allowing the data center network to be deployed programmatically using software-defined networking. It allows both Layer 2 and Layer 3 transport between virtual machines and the underlying Type 1 bare metal servers. VXLAN supports the virtualization of the data center network while still addressing the needs of multi-tenant data centers by offering the necessary scalable segmentation. In other words, now the VLAN identifier is a 24-bit field. Here's an example of a Cisco network, which is very common, connecting two data centers. These could also be two availability zones in a region going across the IP network. Now on the exam, you don't have to be familiar with multi-protocol BGP, the co-op program, or even ISIS, but realize what you have here are leaf switches at the bottom and spine switches at the top. And notice there are no trunk ports between the leaf switches and the spine switches. There's a full mesh. So the things that connect to the leaf switches, for example, your storage area network, your RAID arrays, your hypervisor clusters, they're always only 2 hops apart, and the protocol connecting the leaf switches and the spine switches is intermediate system to intermediate system. Also, there's no more spanning tree protocol, as you have a full mesh. This environment, by the way, is being managed by at least 3, preferably 5 controllers in a cluster. In this example, we have a single cluster of 3 software-defined network controllers. Cisco calls these APICs, or APICs. And instead of connecting to the infrastructure devices using, let's say, HTTPS, let's say Secure Shell 2, or some other management protocol, you're actually sending digitally signed API calls to all of the devices. And since this is being represented logically, it's massively scalable, and you can deploy new leaf switches and spine switches almost on demand. And because of the 24-bit identifier field, you can theoretically create as many 16 million VXLANs in your domain, as opposed to the traditional 4094. Now that is theoretical. From a practical standpoint, you'll see devices from Cisco and Juniper supporting things like 32,000 VLANs. You may also be involved in the logical data center tenant partitioning. This is where your hypervisor clusters come into play. For example, KVM or Citrix Zen or vSphere. So the operator logs on to the shared server cluster, and then in this example, we have 3 tenants, tenant A, tenant B, tenant C. For example, 3 large customers of a cloud service provider. They get partitioned into their own partitions, so they have complete separation from each other, and you can see we have their servers running in their Kubernetes clusters. From a management standpoint, the administrators who log on to the controllers are going to be involved in security management, operating system management, application management, virtualization management of the hypervisor, and the underlying infrastructure management, physical hardware, the storage area network, and the 100 gigabit network itself. In the multi-tenant model, you can use the same physical hardware and hypervisor solution to provide multiple virtual hardware solutions or images to multiple customers. It's important to realize that today, most cloud providers and enterprise data centers are rapidly moving towards or leveraging a zero trust initiative, a zero trust model. So let's finish up this lesson looking at some zero trust access controls, which would be digitally signed API sessions. This can be for user access or entity access to resource objects, or it could be used from a management standpoint. 802.1x port-based network access control at layer 2 and layer 3, and 802.1ae MACsec. .1x will contribute to your network admission control initiative and zero trust, and .1ae is going to provide encryption, origin authentication, and integrity at the frame level. You'll have biometric multi-factor authentication, for example, 2MFA or MFA with fingerprint, ocular scanning, facial recognition, or others. Physical and logical intrusion detection systems with various sensors and monitors, visibility in the Security Operations Center or the SOC, and centralized and automated least privilege principles and separation of duties. We're going to cover several topics, starting with the Cloud Data Center Environmental Layer. The Cloud Service Provider CSP environmental layer is dedicated to environmental considerations, from choosing the site and construction, build or buy, to operations and sustainability. CSPs carefully choose their data center locations based on environmental risks, such as reducing the risk of seismic activity, flooding, fires, and dangerous weather patterns. In fact, the major cloud providers are going to spend large sums of resources as part of business impact analysis to choose just the right site. At AWS, every availability zone has at least 2 data centers. The data center sites are in nondescript locations without public signage. In other words, they don't have the logos and the names of the companies on the outside of the building, like you'd see with a building office or a distribution center. Now, don't be overwhelmed by this diagram. We want to touch on a few things here to look at the physical data center design, and we're not going to cover everything here, but realize that you have to have automation whenever possible. So at the top, we have the transfer switch. That's when we have various power sources. You have emergency power generator integration. And as we learned, we need to have at least 12 hours of diesel, as well as visibility and monitoring. We have DES Micro. This is a grid controller. Basically, it optimizes systems and sites that operate entirely or partially off the grid. So it supports storage, load, solar, and other generators. So a gas generator set, lithium batteries, renewables. Deep in the heart of the data center, we have the remote power panels and the power distribution units. Obviously, we have to have detection and suppression systems for fire and life safety. VESDA, or VESTA, is an aspirating smoke detection system used for early warning applications where the response to a fire is critical. It basically continually draws air into a pipe network through a high-efficiency aspirator, and then a sample of the air goes through a dual-stage filter. Below that, we see a bunch of acronyms. We don't care about Velocirac on the exam. That's proprietary and actually very niche. But BMS is the Building Management System, a building IT control system where you have mechanical and technical elements controlled and monitored, like security, refrigeration, power, lighting, and even notification to firefighting units. Towards the bottom, we see our thermal optimization with white space dynamic cooling optimization and chillers. You have smart power to the server racks, we have weather monitoring stations, and low voltage switchgear, transformers, high voltage substations, and medium voltage power distribution. A big aspect of environmental control in the data center is auditing. Cloud provider data centers are regularly audited by external third parties based on over 2,000 requirements throughout a year. When third-party auditors inspect a data center, they get high and deep visibility and confirmation that the established rules and policies are being followed, often to obtain security certifications and accreditation. Auditing is contingent on the compliance program and its mandates. External auditors may interview employees about how they handle and dispose of media, for example. Auditors may also review security camera feeds and observe entrances and hallways throughout the data center. And they would frequently inspect the aforementioned equipment using electronic access control devices and security cameras. Another example of an area that would be audited for security is the storage area network. A SAN is made up of quite a few different specialty devices, specialty SAN fabric switches, host bus adapters, dual homing servers, and different types of data arrays. Obviously, at the top of the list would be implementing a zero trust initiative. Then, we would use secure management through software-defined security, complete separation of the control plane and the data plane. We would harden all of our switches and servers. We would test our patch management before we deploy the patches. We call that software assurance. We can encrypt data at rest with AES 256 GCM. We would use multi-factor authentication, biometric access to the area, and possibly to different controllers. We would implement 802.1ae MACsec that provides encryption and more on the SAN frames. If we don't want the overhead of encryption, we don't have to do that. We can just use the MACsec GMAC to get origin authentication and integrity. Continue our discussion from the previous environmental objectives and talk about HVAC design considerations. The local climate and weather patterns will definitely impact your HVAC design requirements. And redundant HVAC systems should be part of the design. The HVAC systems should filter contaminants and dust, and they should provide air management that separates the cool air from the heat exhaust of the servers. We'll see this in a moment. There should be racks with built-in ventilation or alternating cold and hot aisles. And today, we should definitely consider energy-efficient systems and, whenever possible, sustainable solutions. On the exam, the recommended temperature, for example in the data center, is 72 to 76 degrees Fahrenheit. The humidity recommendations is 40 to 60%, and backup power supply should be available to the HVAC system based on your business impact analysis, BIA. Here's a diagram showing a data center with hot and cold aisles. Notice we have on the far left our cooling unit, where the cool air passes through the floor tiles, where the hot side of the equipment intake goes. That's our hot aisle. Then we have a cold aisle with cold air return, where cooler air is returned through the floor tiles. And we alternate that between the different rows. Notice at the top, we have a chilled water plant. There's different types of chillers out there. For example, adiabatic cool systems work similar to dry cooling systems, but they incorporate pre-cooling pads. Running water over pre-cooling pads and drawing air through the pads depresses the ambient dry bulb of the incoming air. The depressed dry bulb allows for greater system heat rejection, highly effective in hot, dry environments, while using less water than traditional evaporative units. Adiabatic units also deliver the needed cooling capacity in a smaller footprint and/or a lower fan motor horsepower than a completely dry cooler condenser. We also have to be aware of securing our distribution frames and wiring closets in our building or floors on the campus. We have to gain visibility into all Ethernet and fiber cable runs, as well as the security of MDF, main distribution frames, rooms, and closets. The cable runs can be under the floor, above ceiling panels, or in the walls. We should lock all doors to server rooms and frame rooms. There should be no window access, or if you can, use security windows that have wire mesh embedded in them. We want to use hardened management stations and environmental controls for temperature, fire, gas, and humidity. On the exam, they'll expect you to be aware of multi-vendor pathway connectivity. Uninterrupted service and constant access are critical to the daily operation and productivity of your enterprise. Since downtime leads directly to loss of income, data centers must be designed for redundant, fail-safe reliability and availability. Data center reliability is also defined by the performance of the infrastructure. Cabling and connectivity, backed by a trustworthy vendor SLA with guaranteed error-free performance, will help avoid poor data transmission in the data center. At the heart of multi-vendor pathway connectivity is redundant connectivity from multiple providers into the data center. This will help prevent a single point of failure for network connectivity. The redundant paths should deliver the minimum expected connection speeds, for example 10 gigabit per second or 100 gig for data center operations. An example would be having a data center connection with a direct connect 100 gig to a provider for AWS and a 100 gig express route to Azure. One of the newer topics that was added to the more recent CCSP exam in August of 2022 was the concept of design resilient architecture. A resilient design is the process of designing buildings, facilities, landscapes, campuses, communities to lower the impact of extreme weather and external threats. Resilient design focuses on practical and realistic solutions, and it's often part of your disaster recovery or business continuity planning. Here we see 5 tiers, P1 through P5. Let's go to P5 on the far right and notice that this is a multi-region active-active deployment, and this is indicative of all of the big cloud providers like AWS and Azure, where the design complexity is very high. The operational effort is quite expensive. There's a high cost to implement, a high effort to secure, and it has a higher environmental impact. But from a resiliency standpoint, it offers the highest availability. A multi-availability zone deployment has the lowest complexity, the lowest cost to implement, the lowest effort to secure and operate, and the lowest environmental impact. It's important on the exam to be familiar with the Uptime Institute. The Uptime Institute is the standard bearer for digital infrastructure performance, whose tier standard has been used in thousands of sites in more than 100 countries. Their first tier is the basic site infrastructure. This is a simpler and less expensive solution with little or no redundancy. Only dedicated space for IT systems, a UPS, uninterruptible power supply for backup, line conditioning, and cooling of critical equipment. Any problematic personnel activity will indeed cause downtime. Remember that for the exam. And a second thing to remember for the exam, we're going to look at 4 tiers of the UI, and all 4 tiers must have at least 12 hours of fuel for their generators. Tier 2 is the redundant site infrastructure capacity. This component has additional features beyond Tier 1. There will be downtime for any disconnection from power distribution and power lines. Problematic personnel activity may cause downtime, and unplanned component failure or systems may cause downtime. A Tier 3 site is called concurrently maintainable site infrastructure. Here, you'll have dual power supplies for all your systems. Critical operations can continue if a single component or power element is down for replacement or scheduled maintenance. Unplanned loss of component may cause downtime, but unplanned loss of a single system will cause downtime. Tier 3 is where many modern commercial data centers are today, or at least they should be. Tier 4 represents our cloud service provider data centers. This is the fault-tolerant site infrastructure, the optimal data center offering. It has all the features of the other tiers. It has full redundancy of systems, power, and cooling. A loss of a single element will not cause downtime in a Tier 4 data center. It has fully automated visibility and response systems, and scheduled maintenance is performed without any downtime whatsoever. Make sure you familiarize yourself before the exam with the Uptime Institute, UI. This lesson is all about risk analysis and risk management, and of course from the perspective of a cloud security initiative. But before we dive into that topic, let's define risk. First, we have inherent or total risk. This is risk and vulnerability the organization faces if safeguards or controls are not implemented. It's basically the present posture or baseline of existing risk. Residual risk is the remaining risk after countermeasures are implemented and tested. So basically, residual risk is inherent or total risk minus the implemented controls or safeguards. And then we have 4 ways to handle or treat risk. You can accept risk, where you don't implement any safeguards. This often involves justification in writing or in person, maybe to a steering committee or the decision makers in the C-suite of the C team. There's risk avoidance. This is deciding not to undertake the actions that introduce additional risk. For example, not storing certain types of privacy data in the cloud, or not choosing a particular physical location for your data center. Risk transference or risk sharing is passing the risk to a third party, such as an insurance company with a cybersecurity binder, or maybe choosing a platform as a service or software as a service solution. Another way to transfer risk is to share a cold or hot disaster recovery site with another organization. And then risk mitigation. This is the actual implementation of safeguards that will eliminate or, in most cases, reduce the risk exposure to an acceptable level. It's very rare that we can completely eliminate risk or vulnerability 100%. And realize that risk acceptance, avoidance, transference, and mitigation are not a one-size-fits-all solution. You can apply a different methodology to different assets or asset classes or different scenarios. It's very common for organizations, especially small to medium-sized businesses, to create a risk register, which could often be a spreadsheet with many tabs. This is also called a risk ledger or a log. The underlying spreadsheet can also be supported by a database, of course. And then it can be further represented, maybe using the R programming language, with scatter plots and tables from the source information. A risk register must help support regulatory compliance. It must support your risk assessment and risk analysis and your business impact analysis. It's often a repository of identified risks, impacts or magnitude, various scenarios, and your potential responses. Notice some other categories here are things like time and cost objectives, risk owners, and assumptions or descriptions. Also, over time, the risk ledger or log will be populated with root causes, all based on problem management or after-action reports. Here's an example from Tim Casey at Intel. Notice some of the event types: accidental leak, espionage, financial fraud, misuse, opportunistic data theft, physical theft, alteration of products or services, sabotage, and violent acts. And then we have our actors, the non-hostile actors, the unknown and hostile actors. Here's the takeaway from this table, however. Notice the one actor who checks off all the boxes. Casey has this as the disgruntled insider. I prefer the term compromised insider because you can be a privileged insider who's been compromised. Let's say you have a financial problem or you've been extorted or a drug or gambling problem, but you're not necessarily disgruntled. You may like your company, you may like your boss and your coworkers, but you've been compromised. So the one that checks off all the boxes is the compromised privileged insider, which would be your primary threat, especially in your data center. The most popular and historically used method of risk analysis is qualitative risk analysis. This is a descriptive approach using subjective opinions, history, and scenarios to determine risk levels. In other words, you're qualifying risk based on a scale of 1 to 5 or 1 to 10 relative to other levels. Qualitative risk analysis can be valuable if you have lots of expert judgment experience, you're relying upon best practices, and skillful intuition. It often involves interviewing people, perhaps using the Delphi method, or workshops, or questionnaires and surveys regarding your assets and asset classes, any known risks and known vulnerabilities, commonly experienced threats, and any historical impact over the months or years. It'll often leverage information that exists in the aforementioned risk register or risk ledger. The results of qualitative is often expressed in a heat map. Here, the darker colors represent the areas that we're going to prioritize or focus the expenditure of resources on: time, money, and people. On the vertical, we have probability or likelihood. And realize that you'll have many of these different heat maps based on various assets and asset classes under various scenarios. And we have a scale of 1 to 5. 1 being improbable, 5 being frequent. On the horizontal, we have impact or magnitude, 1 being negligible and 5 being disastrous. Remember, this is relative, so for this to be accurate, you need to have a lot of information, a lot of expert judgment and experience. But whatever assets and scenarios fall under the frequent and critical and frequent and disastrous, that's where you'll begin to spend your resources. Now, even if the organization decides to go to a quantitative model, what they'll often do first is they'll take their existing qualitative analysis and subject it to a semi-quantitative approach. In other words, taking the elements of the heat map and attaching actual dollar values or percentages for impact and likelihood. So, for example, the risk of the event would be 4, which is critical impact, greater than $100 million, and 3, occasional likelihood, which is once in the last 5 years, but not in the last year, to give us a value of 12. So this value of 12, even though it's based on a qualitative relative model, actually has meaningful metrics attached to it. And this is a useful way to leverage the existing qualitative analysis before engaging on an initiative of going to a full-blown quantitative approach. Today, because of the weaknesses of qualitative analysis, we are gravitating towards quantitative risk analysis. This is rapidly gaining popularity due to methods like factor analysis of information risk, or open FAIR. These are scientific or mathematical approaches to getting monetary and numeric results based on several variables: asset values, both physical and logical, and yes, we can apply a financial value to a logical asset; impact, magnitude or severity; probability, the likelihood of occurrence; threat frequency, how often the threat actor conducts the exploit; the threat actor capability, their level of expertise, from script kiddie up to advanced persistent threat actor; the level of existing resistance or difficulty that the target is presenting. The probabilities are based on percentages and using calibrated estimation, and the goal is to get a 90% of accuracy. And by leveraging program evaluation and review technique, PERT, and Monte Carlo simulation software, we can actually meet that goal of 90% accuracy. The goal is not to be perfect, but to have 90% calibrated estimation. There's also the classic Whitman quantitative model with values such as AV, asset value, the value of the asset according to the organization; EF, exposure factor, the percentage of asset loss caused by identified threat; SLE, the single loss expectancy. This is the potential loss if the attack occurs. SLE is the asset value AV times exposure factor EF, or the product of AV and EF. ARO is the annualized rate of occurrence, an estimated frequency the threat will occur within a single year, often based on the risk register or risk ledger. The goal is to have ALE, the annualized loss expectancy. This can be a fiscal year or a calendar year and is a product of single loss expectancy and annualized rate of occurrence. So obviously the results of this model will populate your risk register or risk ledger database, and you'll have various assets and asset classes under different threat scenarios, and then you'll plug in the values of asset value, EF, SLE, and ARO to get a result of annualized loss expectancy. From the standpoint of a cloud provider, they'll often rely on the CSA, Cloud Security Alliance, Cloud Controls Matrix, CCM, as part of their risk analysis and auditing. The CSA Cloud Controls Matrix is a cybersecurity control framework for evaluating cloud computing deployments. It contains 197 control objectives that are organized into 17 separate domains, covering all key aspects of cloud technology. It is a valuable tool for methodically assessing a cloud implementation. It provides guidance on which security controls should be applied by which actor, and in this case, we don't mean threat actor, we mean security practitioner or engineer or architect within the cloud supply chain. The framework is associated with the CSA security guidance for cloud computing and is considered the de facto standard for cloud security assurance and compliance. The CSA also offers the Star Level 1 Security Questionnaire. The most recent version is CAIQ version 4. This questionnaire is now included with the CCM, and it offers an industry-accepted way to document what security controls exist in IaaS, PaaS, and SaaS services, providing security control transparency. In other words, it's a questionnaire that has yes or no answers that you offer to the potential provider early on in the life cycle. For example, after you sign your NDAs, non-disclosure agreements, but before you've signed the Memorandum of Understanding or Memorandum of Action. The cloud consumer and cloud auditor may wish to ask a cloud provider questions to ascertain their compliance to the CCM. It helps cloud customers gauge the security posture of their prospective cloud service providers and determine if their cloud services are suitably secure. This is used most often with third-party software as a service providers, as opposed to, let's say, the big three, AWS, Google Cloud Platform, and Microsoft Azure. One thing you'll notice as you look at the objectives on the CCSP certification is that they duplicate the objectives several times within the PDF file. This is one of those areas. Since they duplicate, I'm going to go ahead and duplicate as well. So we need to remember the different threats to cloud providers and cloud resources. So this is a very important one to look at again. The CSA Treacherous 12 with data breaches, weak identity credential and access management, insecure or unsecure application programming interfaces, APIs, system and application vulnerabilities, account hijacking, malicious insiders, advanced persistent threats, data loss, insufficient due diligence, abuse and nefarious use of cloud services, denial of service, including distributed denial of service bots, and shared technology issues. It's also beneficial to memorize the AWS Guard Duty finding categories, which are backdoor attacks, malicious behavior, credential access issues, cryptocurrency or cryptojacking, defense evasion, or hiding your kill chain activities, discovery or reconnaissance, exfiltration, impact, usually DNS issues, initial access, penetration testing, persistence, policy issues, reconnaissance, stealth behavior, such as disabling CloudTrail logging, Trojans, and unauthorized access, often to object storage. Something else you want to remember is the CSA's best practices for mitigating risks in virtualized environments. You'll definitely have questions on the exam. Risk number 1 is VM sprawl. Risk number 2 is sensitive data within a VM being exposed. Risk 3, the security of offline and dormant virtual machines, for example, Linux or Windows images. Risk 4 is the security of pre-configured or golden images. Risk 5, the lack of visibility into and the control over your virtual networks. This can affect the partitioning between the guests that are running on the hosts. Number 6 is resource exhaustion, making sure that applications are actually virtual machine optimized. Hypervisor security, preventing hyperjacking. Unauthorized access to hypervisors. Do you have least privilege and separation of duties in your hypervisor cluster access? Account or service hijacking through the self-service portal. Workload of different trust levels located on the same server. Often you can use private VLANs in these scenarios. Risks due to cloud service provider APIs. Are they digitally signed? We have to make sure that we're gaining visibility and control of our virtual networks. Consider a hypervisor that can monitor each guest operating system. This is introspection as it is running, if separate tools are not installed to monitor communications between VMs. Implement security technologies that span physical and virtual environments with a consistent policy management and enforcement framework. Create consistent security policy and configuration across the physical and virtual network. Use VM-specific security mechanisms embedded in hypervisor APIs to offer granular monitoring and visibility of traffic crossing VM control and data planes, such as software-defined networking and proprietary solutions like OpenFlow. We also need to mitigate resource exhaustion. That was one of the main threats on the CSA list. Implement appropriate resource allocation and/or reservation policies based on sensitivity and/or risk level classification of your virtual machines. Use antivirus and other security software that is virtualization aware and virtualization optimized. Implement mechanisms to minimize resource contention, including staggering the scanning of VMs on the same physical server, using agentless deployment of antivirus software, implementing distributed storage resources, and implementing a workload affinity policy. Also, define and implement a standard operating procedure that detects VMs that are throttled due to resource exhaustion. In the lesson, we're going to look at cloud risks and mitigation strategies from a different point of view. We're going to look at the top 5 from the point of view of VMware. So, according to them, we've got first, insider threats, and that's data theft and data loss. Second, misconfigurations. Third, account hijacking. Fourth, denial of service attacks. And the fifth cloud risk is malware. Let's break down each one of these and look at mitigation strategies. For insider threats, specifically data theft and data loss, we want to deprovision access to resources immediately whenever there's a personnel change. We call these movers or leavers. Implement data discovery and classification technologies. In other words, make sure you always know what you have and what its status or posture is. Look for signs of suspicious activity trends. We can use SIEM and SOAR systems or user behavioral analytics. Monitor privileged users. Ensure that privileged access is done on a per-session basis and sparingly for specific tasks. Implement user behavioral analytics, UBA, where a baseline behavioral profile of each user is generated. Track attempts to access disabled accounts, along with any other anomalous attempts to access data or gain elevated permissions. Cultivate company-wide cloud usage and permission policies and programs. For example, rely upon single sign-on and multi-factor biometric authentication and authorization. Preferably, an ocular factor, facial recognition, or using QR coding from companies like ID Ramp. Introduce data access governance. Enable centralized logging so incident response can be better performed. It's one thing to implement data discovery and classification, but you must enforce that policy and perform your due diligence to make sure it's always up to date with an automated inventory database. Enable those UBA tools. Establish data remediation workflows. Implement DLP, data loss prevention engines. And consider outsourcing breach detection by using a cloud access security broker, CCSP, to analyze egress data in transit actions. Consider companies like Cisco, Fortinet, Palo Alto Networks, and others. Misconfigurations. Establish baseline configurations and frequently perform configuration auditing to check for drift or creep from the original baselines. Employ continuous monitoring, SEAM and SOAR, to detect suspicious changes. Look for solutions from companies like Splunk and Azure Sentinel. Investigate incidents promptly. Oblige data owners to periodically confirm that permissions match employee roles. Validate that all access rights align with data protection. Whenever possible, revoke excessive or inappropriate access rights. Strictly enforce least privilege, segregation of duties, dual operator, and mandatory vacation policies. Number 3, account hijacking. Implement Identity and Access Control Management, IAM. Use multi-factor authentication. Require strong passwords or implement passwordless technologies. Monitor all user behavior. Identify and revoke excessive access to sensitive information. Remove unused accounts and credentials. Apply the principle of least privilege. Notice, by the way, there's redundancy here because we'll use some of the same administrative and technical controls as mitigation and countermeasures for these top 5 threats. Control all third-party access. Train employees on preventing account hijacking. Number 4, denial of service attacks. Secure the network infrastructure with a web application firewall or a web security gateway. Implement content filtering. Use load balancing to identify potential traffic inconsistencies. Have automated methods for learning about new botnets and new DDoS attacks. Leverage managed cloud solutions such as AWS Shield Advanced, which works hand in hand with a web application firewall. And number 5, malware. Implement next-generation cloud-based antivirus solutions. Consider running 2 different vendor products on endpoints and servers, for example, Sophos and Malwarebytes. Perform regular comprehensive data backups and conduct periodic restoration and recovery tests for ransomware malware. Train employees on safe browsing and downloading habits. Consider advanced web application firewalls from vendors like Fortinet,